Good morning, companions. Our team is conformed by me, Emilio Borja Rivera, Yael Osmaro Bravo Sustaita, Carla Don Juan Martinez, and Manuel Prado Aranda. Below we will show you a video of our project of asymmetric bending in a resist beam. The purpose of this experiment was to verify that experimentally the theoretical calculations with the following previously established parameters, which are asymmetric load of 200 newtons and 45 degrees with respect to the y-axis, deformation on the x-axis of 1 centimeter, deformation on the y-axis of 1 centimeter. First, we will define the concept of asymmetric deformation with its respective formula. This is, the deformation in the y-axis is equal to the load of the cosine of the angle to which it is the same, for the length of the beam to the cube over 3 by the Young's modulus of the moment of inertia with respect to c. Similarly, the deformation in the z-axis is equal to the load by the sine of the angle to which it is the same, by the length of the beam to the cube on 3 by the Young's modulus for the moment of inertia with respect to j. The total deformation is equal to the root of the deformation in j squared plus the deformation in z squared. With this in mind, we know that we have the load, the angle, and the length, and the deformations in j and z. As can be defined in the deformation formula, there are two unknowns, Young's modulus and the moment of inertia. Each of them depends on the other. This is, if the dimensions of the beam and its geometry are known, the Young's module can be calculated. Subsequently, search for the material that meets the needs and the requirement of the problem. Development of the problem. It was started by proposing a cylindrical beam of circular cross-section with a diameter of 50 mm. Taking this into account, we can calculate its Young's modulus by means of the equation shown above of deformation by clearing Young's model, but for this case, the moment of inertia will be calculated as P by diameter at 4 out of 64. As it was not possible to find a material whose Young's modulus was similar to the one calculated, the use of the white pine wood was proposed since it is cheap, commercial, and easy to work, but now with a square cross-section. The calculations were made in maple for a beam of square cross-sections, and they are shown below. The government page of Fichas técnicas sobre características tecnológicas y usos de maderas comercializadas en México was found. The Young's modulus, elasticity or bending, for white pine wood ranges from 8.8 gigapascals to 12.7 gigapascals. As shown by a range of values, 3 possible measurements were calculated for the sides of the cross-section of the beam, which were, for a module of 8.8 gigapascals, the measurements of the side of the cross-section was 29.93 millimeters. For a module of 10.7 gigapascals, the measurements of the side of the cross-section was 28.51 millimeters. For a 12.7 gigapascals module, the measurements on the side of the cross-section was 27.31 millimeters. To have a result more approximated to the real value, and the average of the 3 values was made. This average was 28.58 millimeters. The measure was used for the manufacture of our wooden bar. Mounting. The whole wooden structure was made for the previously mentioned reasons. As shown in the image, a horizontal base was installed to fix the wall to which the beam was embedded. A square hole was made where a part of the beam was inserted, ensuring that the free part is 50 centimeters. To fix the bar firmly, a vertical screw and 2 horizontal ones were placed. At the end of the beam, a ring was placed exactly in the center of the cross-section, this in order to hold the load. To achieve a load at 45-degree angle, a vertical bar was mounted to which the hole was made at the height of 26.3 centimeters with respect to the base. This in order to achieve asymmetric loading. Test. In the laboratory, 4 weights of 5 kilograms and a weight of 500 grams were used. They were placed from 10 to 10 kilograms in order to observe how the bar was deformed. The ring that is at the center of the bar is initially at a height of 28.5 centimeters with respect to the base, and the horizontal length was 9 centimeters with respect to the side wall. When applying the full load, a final height of 27.5 centimeters was measured with respect to the base, and a final horizontal length of 10.5 centimeters with respect to the side wall. The difference of the initial and final lengths results in the deformation that was 1 centimeter and 1.5 centimeters respectively. The test was carried out again to verify that the values obtained in the last test were adequate, and it was rectified that it did give the same deformation for the second test. Results. The deformation in the horizontal axis was not expected of 1 centimeter because there was a small error in the placement of the loop at the moment of putting the load, since it was not exactly at 45 degrees, which caused a slight variation. Conclusion. There are several parameters that must be taken into account for the realization of a good project. Apart from that, we must also take into account that there are errors that could affect our results at the time of physical experimentation. However, as engineers, our duty is to know how to solve this, and the results obtained in an analytical manner should be approximate to real life.